The unfettered use of TCP/IP connections between JVMs in Java remote method invocation. Here you can see the unfettered use of TCP/IP connections between JVMs. Here you can see the transport layer makes the connection between JVMs. All connections are stream-based network connections that use TCP/IP. Even if two JVMs are running in the same physical computer, they connect through their host computer's TCP/IP network protocol stack. This is why you must have an operational TCP/IP configuration on your computer to run JVMs. And this diagram shows the unfettered use of TCP/IP connections between JVM. As you know, TCP/IP provide the persistent stream-based connection between two machines based on an IP address and port number at each end. Usually, DNS is used instead of IP address, which means you could talk about TCP/IP connections in the current release of RMI. TCP/IP connections are used as the foundation for all machine-to-machine connections. On top of TCP/IP, RMI uses wire level protocol called Java Remote Method Protocol, JRMP. JRMP is a proprietary stream-based protocol that is only partially specified, is now in two versions. First version was released with Java 1.1 version of RMI and required to use skeleton classes on the server. The second version was released with the Java 2 SDK. It has been optimized for performance and does not require skeleton classes. There are versions like RMI IIOP, which which is available in Java 2 SDK version 1.3. RMI transport layer is designed to make connection between client and server even in the face of network obstacles. While the transport layer prefers to use multiple TCP/IP connections, some network configuration only allow a single TCP/IP connection between a client and server. Some browsers restrict applets to a single network connection back to their hosting server. So here you can see JRE there, and host OSs are there. These are connected through the network layer, and also this JRE and remote JRE is connected with the different host OS through the network layer. As a separate description, on top of TCP/IP layer, RMI uses wire level protocol called Java Remote Method Protocol, JRMP, which work like this. Now, step 1, object that require remote behavior should extend the remote object class, typically through unicast remote object subclass. The unicast remote object subclass exports the remote object to make it available for serving incoming RMI calls. Exporting the remote object creates a new server socket which is bound to a port number. A thread is also created that listens for a connection on that socket. The server is registered with the registry. The client obtains details of connecting to the server from the registry. Using information from the registry, which includes the hostname and port details of the server's listening socket, and client connects to the server. When the client issues a remote method invocation to the server, it creates a TCP/IP connection object which open a socket to the server on the port specified and send RMI header information and marshaled argument through this connection using the stream remote call class. On the server side, when the client connects to the server socket, new thread is assigned to the deal with the incoming call. Original thread can continue listening to the original socket so that additional calls from other clients can be made. A server reads the header information and creates remote call object of its own to deal with unmarshalling RMI arguments from the socket. The service call method in the transport class services the incoming call by dispatching it. The dispatch method calls the appropriate method on the object and pushes the result back down to the wire. If the server object throws an exception, server catches it and marshals it down to the wire instead of returning the value. And back on this client side, the return value of the RMI is unmarshaled and returned from stub back to the client code itself. If the exception is thrown from the server, that is unmarshaled and thrown from the stub. As an example, we can consider now this is the end of my presentation. Thank you very much for watching it.